It'll start tomorrow.
Oh, it starts tomorrow. Okay. Okay. Just once. Okay. So today we begin with the mole concept. Okay.
Okay.
Okay. Now, why we have to bring in a mole concept idea?
Uh,
Because atoms are too small to be seen by our naked eyes, right?
yes.
So the biggest problem was how do you count them?
Mm-hmm.
Okay. Because if you buy potato, you buy apple, you can go to the shop, tell him, okay, weigh 1 kilo of apple or potato or whatever you want, right?
Mm-hmm. Yeah.
But when you look at the number of potatoes or number of apples, it will be different for in 1 kg, right?
Yes.
So 1 kg doesn't mean there will be 10 apples and say 10 potatoes. It might be 10 apples and 15 potatoes.
Mm. Yeah.
So from the kilo point of view, it is okay. You have weighed the same amount.
Mm.
Okay. And now
Yes.
when you come to atoms and all that, the kilo also doesn't work out because kilo is too big a scale for us to even look at.
Mm.
Okay, because they're so light.
Yeah.
So even gram, milligram, so we cannot make a sort of decision on how much we have, right? Because we just can't weigh them, right?
Mm. Yes.
Okay. So one of the things which happened was, that. So how do you measure them? Okay.
Mm.
One of the things very common is when it comes, initially all the work was done on gases.
Gases. Okay.
Okay.
Mm-hmm.
So gases is where the whole story begins. So what are the things you can measure in a gas?
The volume of the
Volume, correct?
gas, the
Huh?
mass, the
What is that?
volume, the
Pressure of
mass.
measure?
Huh?
Pressure. Pressure of a gas.
Pressure.
Yeah.
Yeah.
Pressure,
Mm-hmm.
volume, you can also measure temperature.
Temperature. Yeah.
Okay.
Yeah.
So these are the so now they are telling us some information on the atom or molecules of gas in
Mm-hmm.
terms of what we call as what we can measure.
Mm. Yeah.
Pressure, volume, temperature, things like that. So
Mm-hmm.
what Amadeus Avogadro, Avogadro in 1811 proposed that
Mm-hmm.
equal volumes of all gases
Mm-hmm.
at the same temperature and pressure will
Mm-hmm.
have equal number of molecules.
Equal volume of gases in equal temperature and
Pressure
pressure.
will have same number of molecules. Okay.
Okay.
So if pressure is same, volume is same, temperature is same, then it will have same number of molecules.
Okay.
Suppose you take 1 atmosphere pressure, so volume is say 1 liter, okay, and
Mm-hmm.
temperature say 25 degrees centigrade.
Mm-hmm.
Then they will have you take say nitrogen or oxygen or carbon dioxide, whatever you take,
Yeah.
they'll have the same number of molecules, is what he made a statement.
Mm. Okay.
Okay. Now, very few people could appreciate what he's saying at that time. We are talking about 1811.
Mm.
Okay. But
Yes.
now, what was so very interesting is can we, in terms of pressure, volume, and temperature, make a prediction on the number of molecules? This is what is, and so they use what is called kinetic theory of gases.
Okay, so to come up with if they have equal volumes of gases in equal temperature and pressure.
So based on that, he did a lot of, we will do some calculations today.
Oh, was it called kinetic?
Theory. Okay, that is, gases are in constant motion.
Okay.
So they are hitting on the wall. So they are creating a pressure.
Mm-hmm.
If you reduce the volume, the pressure increases. That's what Boyle's law told you.
Yeah.
If you have a fixed amount of gas, then if
Mm-hmm.
you increase the volume, pressure decreases. If you decrease the volume, pressure increases, assuming temperature is constant.
Yeah.
Okay, so this is what is called Boyle's law.
Mm.
So people did study. Then people also studied what will be the volume of a gas if I keep on reducing temperature.
Mm.
That is, on the y-axis, you have temperature. Okay. Sorry.
Yeah.
I mean, x-axis you have temperature and y-axis say you have volume.
Mm.
Okay, now you take any gas
Mm.
and keep on cooling and measure the volume.
Yeah.
What they found is at minus 273 degrees centigrade,
Mm-hmm.
the volume of a gas was 0. That is, no gas existed below minus 273 degrees.
Oh, okay.
So you don't, there may be liquid or a solid, but you don't see.
Yes.
So what happened? That minus 273 became the starting point to measure volume. Okay, so temperature is always measured as from minus. So suppose it's 25 degrees, means the absolute scale we talk about, it is 273 plus 25.
So the temperature we start counting from negative 27
Negative,
degrees.
because it is 0 volume.
Okay.
So doesn't matter what the volume is, but the point is you always say temperature is measured. So this is called to minus 273 degree Kelvin. So Kelvin was the man who discovered that below minus 273 nothing exists. All are liquid or solids. So even to date, we don't know of any gas which remains a gas below minus 273.
Okay.
So that became an absolute scale.
Okay.
Okay, so you will always see when we say temperature, it is also always 273 plus. If you talk of positive temperature. Okay.
Yeah.
So for example, minus 40 degrees and 273 minus 40. You understood? So the 273 is the minus 273 is the starting point for any gas. So note this point, okay? So when you plot volume versus temperature, and if you keep on cooling, minus 273, no gas will exist.
When you plot volume versus temperature.
Volume on the y-axis and the on the x-axis, it is temperature. Okay, say 0, minus 10, minus 20, minus 30, minus, like that, you go up to 300, so minus 300. Just as a scale. And if you plot, suddenly you find at minus 273, it becomes 0. For example, helium is one of the things most difficult to liquefy.
Okay.
So if you take helium and you'll have to go up to nearly minus 273 to make it 0 volume.
Okay.
So that is why we start to, so you remember that, because most of the things today we will be talking about is pressure, volume, temperature, and from that, how do we derive? So this is an important point you must remember. Why we always say temperature is 273 plus whatever it is. Suppose it is 30 degrees anyway, 270, when we do the calculation in Boyle's law. Okay.
Yeah.
In fact, if you remember, pressure is directly inversely proportional. If pressure increases, volume decreases. So they say pressure is directly proportional to 1 by V. Pressure is directly proportional to 1 by V. Okay.
1 by V. Okay.
Yeah, because pressure increases, volume should decrease. So if volume increases, pressure should
Increase.
okay, or volume decreases, pressure should increase. So Boyle's arrived that when you observe that, when he took a fixed amount of gas and tried to measure, because you remember Avogadro said equal volumes of all gases at the same temperature and pressure have equal number of molecules.
Yes.
Okay, so now he has to. So Robert Boyle those days studied the behavior of gases, and he found that pressure and volume are inversely related at constant temperature. Suppose you were to do the experiment 25 degrees, pressure and volume are the same.
Yeah.
Is this clear to you now?
Yes.
So pressure is direct proportional 1 by V. So one of the way we write is pressure into volume is equal to constant K. Assuming temperature is constant.
Okay. Yeah.
Now we'll play around only pressure, volume, temperature. And somewhere we'll introduce number of molecules. Okay.
Okay.
Okay, so we'll come back. So similarly, if you study pressure and volume, suppose you were to study volume and temperature, or pressure and temperature, keeping volume constant. What do you see? Suppose volume.
They're directly proportional.
So they'll be directly because if you increase pressure, temperature increases.
Yeah.
So they're directly proportional. So what happens is that the similarly volume also, if you increase, temperature falls down. Okay. So people studied all these components because this was easily measurable, because there were equipments available to measure temperature, because thermometers were available. There are volume, you had capacity to measure them. Okay.
Yeah.
And you had this thing to measure pressure. So you will see that all these early theories depended upon just these parameters which are measurable. And the beauty of all of them is that they started correlating to what is happening at the microscopic level. Because you can't see the atoms or molecules, right?
Yeah.
So pressure volume gave an impression of what is inside the behavior of gases.
Yeah.
You understood? So you now we are getting into a domain. We are trying to talk about something which we can't see in terms of pressure, volume, temperature, and we have assumed that the number of molecules are constant in that measurement. So, and Avogadro had said equal volume of all gases at the same temperature and pressure have equal number of molecules. You understood?
Yes.
Any confusion now?
No.
Okay, so once this foundation is clear to you, we can start moving ahead.
Okay.
Is that clear?
Okay. Yes.
Now let us come to just one minute. Okay. Now let us understand Avogadro's number. Okay.
Okay.
So to understand Avogadro's number, the mole concept is very important. So mole is a new way, just like you talk about kilograms or this thing like that. Now we are introducing a concept called mole.
Mhm.
Okay.
Yeah.
And you already know that if you look at that is where periodic table becomes very, very important.
Mhm.
Because periodic table gives the atomic weight of all the things.
Yes.
Hydrogen is 1, helium is 2, atomic weight is 4. So everything the weight is given, right?
Mhm.
So when we talk of mole, suppose you take 1 mole of hydrogen, means that is 1 gram of hydrogen atom.
Mhm.
That will have Avogadro number of molecule atoms.
Okay. Yeah.
Okay. Similarly, if you take helium, okay, whose
Mhm.
atomic weight is say 4, okay.
Mhm.
If you take 4 grams, that will have Avogadro number of molecules.
Mm.
So the
Yeah.
periodic table tells you how to calculate mole.
Mhm.
Okay, for example, say if you take sodium chloride, open the periodic table.
Okay. Just a second. Yeah.
So if you take sodium, what is the atomic weight given?
22.99.
So 23 roughly you take, right?
Yeah. Mhm.
And chloride,
Chloride is 35.45.
So if you add these two, okay,
So
1 mole of these two, that is, so suppose you take sodium chloride, it will be 23 plus 50, 35 point.
58.44.
Okay, so if you take 58.44 grams of sodium chloride, that is your salt,
Mm-hmm.
it will have 1 mole of or Avogadro number of molecules.
So that is 1 mole.
That is 1 mole. So remember that the atomic weight is very much. So if you are given any, for example, say they say lithium chloride, 1
Mm-hmm.
mole. Or what is the weight of it if they are? So you should be able to add the atomic weights and tell this is what it is.
Okay.
So that is why the periodic table becomes very important, because that tells you what is 1 mole.
Mm-hmm. Yeah.
You understood?
Yeah.
So,
Mm-hmm.
so whenever you do, for example, say ammonia,
Yeah.
what is its this thing, molecular weight?
Ammonia. Uh,
Ammonia is what? So you must remember the formulas, okay? Ammonia is
okay.
NH3.
NH3.
Okay,
So
because
that
nitrogen has it. So now now one thing you should revise is how to form the bonds.
bonds. Yes, I do have to do
We have
revise.
we'll do one revision on it, but today let us focus on the mole concept. Okay.
Yeah.
So when you take ammonia, it is
17.034.
whatever. Okay, 14
Yeah.
plus 3, 17. Okay. So now
Mm-hmm.
somebody says nitrogen. Now look at the reaction: nitrogen plus hydrogen
Yeah.
going to ammonia.
Mm-hmm.
So first thing you'll have to do whenever you have an equation is balance the equation.
Balance the equation. Yes.
Okay, and nitrogen is always N2.
N2. Mm-hmm.
It occurs always in nature as N2.
Mm-hmm.
Hydrogen occurs as H2.
Mm-hmm. Yeah.
And it goes to make NH3. So how will you balance? So number of nitrogens, hydrogen should be same on the left-hand side and right-hand side. So how will you make that?
To balance it.
Hmm?
I don't think I've learned about balancing the
Yeah,
equation.
but I'm now teaching.
Okay.
So
You
how
just
many
have
nitrogens are there on the left?
1.
1, but that is N2.
So 2
Yeah, the
nitrogen
two
atoms.
nitrogens there, right?
Yeah. Uh-huh.
Hydrogen is also 2.
Hydrogen is also 2. Mm-hmm.
That goes to make ammonia, but ammonia has only 1 nitrogen
Yeah. Mm-hmm.
and hydrogen is 3 there.
Mm.
On
Yeah.
your left hand side, it is 2.
Mm.
So if you multiply ammonia by 2, 2 ammonia.
Yeah.
So nitrogen gets balanced. Number of
Yeah.
nitrogens on the left is equal to number of nitrogens on the right hand side.
Yes.
Whereas the hydrogen has become how much? 6.
6.
6.
Mm-hmm.
So how many hydrogen should you have on the left hand side?
3. Wait, no.
Equation will
2.
be nitrogen plus 3H2 goes to make 2NH3.
Oh. Okay.
Okay, so this is how you balance an equation. We'll do some more problems on balancing, don't worry. But first understand the concept.
Yes. Mm-hmm.
Concept is the number of atoms on the left hand side should be same as the number of atoms on the right hand side. Left hand side should balance with right hand side. So
Mm-hmm.
you multiply, you may reduce, whatever you do.
Okay.
Okay.
Yeah.
Now look at this reaction. Try to appreciate this reaction. So to make 1 molecule of ammonia,
Mm-hmm.
okay, 1
Yes.
molecule. Now we are talking. So how much nitrogen are getting assumed?
2
1 by
nitrogens.
2. No, half of nitrogen. No,
Oh. Okay.
because half only is required for making 1 molecule of ammonia. No.
Yes. Mm-hmm.
Okay. Now
Mm-hmm.
hydrogen is 3,
Mm-hmm. Yes.
but here it is 3H2. So you'll have to now bring down to 1/3.
Mm-hmm. Okay.
So it will become 2/3, isn't it?
Mm-hmm.
So if you look at it, when the reaction happened, 1 molecule of nitrogen plus 2 molecules of 3 molecules of hydrogen. 1 molecule of nitrogen plus 3 more hydrogen will give you 2 molecules of ammonia.
Mm-hmm. Yeah.
Understood?
Mm-hmm.
So the balancing equation tells you how many are reacting.
Okay. Mm-hmm.
The idea clear to you?
Yes.
So this is very important in the whole. So whatever reaction you do, you must first balance the equation.
Mm-hmm.
So balancing equation itself, we can do a whole series of problems.
Okay.
Okay. But first understand that balancing is very important before you proceed.
Okay. Yeah.
Now, if you see in this reaction, there is
Mm-hmm.
1 molecule of nitrogen
Yes.
and there is 3 molecules of hydrogen. So there are
Mm-hmm.
4 molecules on the left hand side.
Yes. Yes.
Whereas how many molecules are on the right hand side?
4.
There are only 2 molecules of ammonia, right?
Oh. Okay. Yeah. Mm-hmm.
So now, if you want to push the reaction to the right,
Mm-hmm.
so what you should do, if you want to make more ammonia, what should you do?
Add more atoms of nitrogen and hydrogen.
No, that is one way. But you don't add anything, but you can play around with pressure and volume.
Increase the pressure and temperature.
Yeah, pressure, temperature, and volume.
Okay.
So
Mm-hmm.
now what happened? You can increase the pressure.
Mm-hmm.
They will occupy less space, so more will get converted into ammonia.
Mm-hmm.
You understand? So when an engineer says, okay, I have to produce ammonia, then he will say, I need a high pressure, smaller volume. Decrease the volume, increase the pressure. This will get converted into ammonia.
Mm. Yeah.
You understand? This is called Le Chatelier's principle.
Okay.
So what I mean, if you want to make commercially a product, you need a reaction chamber where the pressure can be increased, volume can be decreased. Okay. And if naturally you increase the temperature, because temperature always pushes the reaction to faster to the forward, right?
Yeah.
So this is the principle by which the whole technology for ammonia was made.
Mm.
You understand?
Yeah.
So there is so much information in that equation to tell you how to go ahead.
Mm. Yes.
You understanding what I'm saying?
Mm-hmm.
So it
Yes.
is a concept you have to appreciate that we all the engineers chemically play only around with pressure, temperature, volume, and catalyst. Because catalyst accelerates the reaction.
Yes.
So you remember an equation also tells you how to go about making that product.
Mm-hmm.
You understand?
Mm-hmm.
So this is one of the key. So this equation is a very powerful thing. If it is balanced, it will tell you. So now you realize that if you want to say you want to make 1 kilo of ammonia,
Yes. Mm-hmm.
can you tell me how many grams of nitrogen and how many grams of hydrogen is required to make 1 kilo of ammonia? What is 1 kilo of ammonia? 1000 grams, right?
1,000 grams. Yes.
1000 grams, right?
Mm-hmm.
Now, what is the molecular weight of ammonia?
Molecular weight of ammonia is
You did it
17.034.
7. So put it as 17 grams for comfort,
Mm-hmm.
right? So 1 more, 17 grams is 1 mole.
Yes.
So 1000 grams is how many moles? Do that.
17034.
17?
034. Wait.
No. Be careful. 17 grams is 1 mole, right?
Yeah.
1000 grams is 1000 divided by 17. No.
Oh, I thought you were asking. Okay.
No, now we are trying to calculate the number of moles.
Mm-hmm.
Because moles is the only way you can do the calculation.
58.7.
How much?
58.7
Okay, so 15.87 moles, right?
moles.
Okay. So if you want to make 15.87 moles of ammonia,
Mm-hmm.
okay,
Yeah.
okay, this 15.87 moles you want. So how much of nitrogen do we need on the left-hand side?
You have to find the atomic
It
weight
will
of
be the same.
nitrogen.
What is that?
You have to find the atomic weight of nitrogen and then find it.
Yeah, correct.
So 14.14.
So take it as 14. So it becomes
Yeah.
nitrogen become 28 grams.
Yes. Mm-hmm.
Okay,
Mm-hmm.
right?
Yes.
And what about hydrogen?
6.
6 grams, right?
Mm-hmm.
Okay.
Mm-hmm.
So now if you had if you have 17 grams of nitrogen,
Mm-hmm.
how much? 6 grams of hydrogen.
Yes.
How many grams of ammonia will be produced?
Is at 28 plus 6. Just 34 grams.
Ideally, that is, you are assuming that all the nitrogen and hydrogen have been consumed to make ammonia, right?
Yes. Mm-hmm.
Okay. So now calculate now. So you can see that the mass has got balanced.
Mm-hmm.
This is what we call mass balance.
Yeah.
Okay. Now let us get back to 1 kilo ammonia. Now you tell me how much of hydrogen is required, how much of nitrogen is required.
So you would, since 34 is the whole, you would just find what is 28 of 34.
So first we must find out the number of moles there.
Yeah, which is 28, right?
Mhm.
So 28 over 34 times 1,000.
No, you don't have to divide. No. Look. Molecule wise, one is to one is reacting. No, you have taken everything in grams.
Yes.
So you've already arrived. Now I'm talking about, I want to make 1 kilo of ammonia.
Mm-hmm.
So tell me how much of nitrogen and how much of hydrogen will be required. So you already arrived that ammonia is how many moles it is? 15 point something you said, no?
17. Yes, 17. I said 17 moles.
No,
17.
1000 divided by 17, how much did you get?
1000 divided by 17 is 58.
58. Okay, 58 moles, right?
Mm-hmm.
So 58 moles means 58 moles is here, means how much? So now calculate 58 moles is on the right hand side, right?
Mm-hmm.
Okay,
Yes.
so 58 moles means now your nitrogen will also be, because you are balanced, so it has to be 58 moles.
Mm-hmm. Yes.
And hydrogen should be
58 as well.
58 ones. So now 58 moles, if we take, how many grams it comes out to nitrogen and how many grams does it work out to hydrogen?
So then we found out that it's 28 grams of nitrogen atom,
Is
nitrogen
one mole.
molecule, and
One
yeah,
mole.
and then
So
6
58.5
of
moles is also.
So we found out 28 is 1 mole. How much is 58 grams?
28 grams is 1 mole. Now you have 58.5 moles, no?
Yeah. Okay.
So
So you just 58
moles is
times
how many grams?
28.
Huh?
1,624.
So write down 1,006 and nitrogen.
Nitrogen would be 348.
Okay, so that many grams you'll have to take to make 1 kilo of ammonia.
Oh, okay.
You understood?
Okay. Yeah.
So this is what they ask you in the Olympiad.
Mm.
This is one of the ways to look at the problem. That I want to make 1 kilo of this. This is the reaction given. Tell me how many grams of hydrogen I need and how much of that to make 1 kilo of ammonia. Are you comfortable now?
I need to know more questions.
No, we'll do more. But
Yeah.
the basic logic you understood, no?
Yeah, I did.
The logic is, and moles is a very important. Moles tells you number of molecules.
Mm-hmm.
You understood?
Yeah.
So let us do some more simple problems. Okay.
Mm-hmm.
Hydrogen plus oxygen goes to water. Write the equation. H2 plus O2 goes to
I'm sorry, what?
water.
H2? Okay.
H2 plus O2
Yeah.
becomes water, H2O.
H2O. Yeah.
Now first balance the equation.
So it would be 2H2O2.
How 2H2O?
Wait.
So if you take oxygen, it will become 2H2. Suppose you make it 2H2O on the right hand side.
Mm-hmm.
Okay, so how many oxygens are there on the left hand side?
There's 2.
2. And on the right also?
There's 2.
2. Now look at hydrogen. How many hydrogens are on the right hand side?
4.
4. So whereas on the left hand side?
There's 2.
2. So you multiply it by 2, so it becomes 4.
So on the left hand side, you just do 2. You just add 2.
O2 plus 2H2 gives 2H2O.
Okay.
You understood?
Okay. Yeah.
So number of atoms on the right hand side and number of atoms on the left hand side should be same.
Mm-hmm. Okay.
This is called balancing.
Mm-hmm.
Okay.
Mm-hmm. Yes.
You want to do some more balancing?
Yes. I'm a bit confused with that.
Yeah, we can. There's no big deal about it. But I want you to. Now you yourself think of some reaction. No?
Mm. Carbon dioxide.
Ag. Hello.
Oh, okay. I was going to say we can do carbon dioxide.
Take it. Good example. Carbon plus oxygen going into CO2.
So C2O2.
Carbon is always C, no? Carbon is solid.
Okay.
Plus oxygen.
Which is CO2 is equal to
CO2. So what happens? Is it balanced or not?
it is balanced. It
CO2.
is balanced.
So you don't have to do any balancing.
Oh, okay.
Okay.
Mm-hmm.
Understood?
Mm-hmm. Yes. So we only balance equations where atoms exist in molecules in the natural state.
Yeah. For example, let us take an example.
Mm-hmm.
Yes, Ag
Yeah.
plus chlorine
Uh-huh.
goes to AgCl.
Mm-hmm.
So chlorine is what? Cl2.
Cl2.
So Ag plus Cl2 going to AgCl.
So we have to equate for the 2 chlorine. That is the 2 chlorine atom core. So you just multiply AgCl by 2.
Yes. And now silver, what happens on the left hand side?
You multiply that by 2 as well.
Exact. 2Ag plus Cl2 gives 2AgCl.
Okay. Okay.
You understood?
Yes.
So this balancing is very, very important. Okay. Once you do the balancing, now let us go to carbon plus oxygen going to CO2. Say I want to make, say, 1 kilo of carbon dioxide.
Yes.
So calculate how many grams of carbon is required and how many grams of oxygen is required. How many? From the equation, calculate.
Okay, so first we have to see how many moles is 1 carbon and 2 oxygen.
Correct. So the equation already is telling 1 carbon atom reacts with 1 molecule of oxygen to give 1 molecule of CO2.
Yeah.
Now I want to make 1 kilo of carbon dioxide.
So
you have to calculate CO2. What is the molecular weight?
12 plus 2 times 16, which is 44. So 44 is 1 mole of carbon dioxide.
44 grams is 1 mole.
Yes.
So 1000 grams is how many moles?
1000. So 1000 divide 44 is 22.7.
22.7
moles.
Units.
Moles.
Moles. So you need how many moles of carbon?
22.7 moles of carbon.
Correct. And how many moles of oxygen?
22.7 moles.
So now convert these moles into grams.
So
1 mole is 12 grams.
1 mole is 12 grams.
So now how much you have?
12 times
22,
22,
whatever you got the value.
272.
Ah.
272 grams of carbon and
Just 1 minute. 1 minute. 1 minute.
yeah.
I'll just give you a call back in an hour. Hello. Hello.
Hi. Yes.
Hello.
So I found out that there's 272 grams of carbon and 363.2 grams of oxygen.
Okay. Okay. So now you understood.
Yes.
So now do for the silver chloride also 1 kilo silver I want to make.
1 kilo of silver. So AgCl.
So no, silver chloride. I want to make 1 kilo of silver.
So that's AgCl, right? Plus. So 143.35 grams is 1 mole. How much is 1000 grams? Okay. So you would need 755.3 grams of silver.
Yes.
And 248.15 grams of chlorine.
Right? So now you understood.
Yes.
And you can already see there's a mass balance also. Number of grams you take is what you're getting there also. If you add up the left hand side weights and the right hand, it will be 1000, right?
Yes.
So mass balance is also very important. So if you do the mole, the mass balance will come.
Okay. Yeah.
So now you understood this balancing now.
Yes, I did.
Okay. No confusion?
No.
So they will always ask you that only. Last time when we did some problem, they were asking, how much will be the yield?
Yeah.
So you balance the equation and do it.
So you just have to just understand what they're asking, and then you can just do the molds and the.
So mole is the central theme in the whole thing.
Okay. Yeah.
Yeah.
Yes.
Now let me see whether I can give you some. I'm just trying to look at it because I wasn't sure how you picked this up. So I accordingly, on the spur, I'm making them. Okay. So let me think of some very nice reactions. Say, in fact, we can do for a whole range of things actually. Can you think of some reaction which you are familiar with?
Nitrogen and oxygen.
Okay, good. Nitrogen plus oxygen going to say NO2.
NO2. Yeah.
So now balance the equation.
So it's N2O2.
Plus
It's hot,
O2
so
going to NO2.
NO2. So you would multiply that the right hand side by 2. So it
Correct.
becomes 2n plus O2.
Yeah.
Isn't that it?
Mm-hmm.
So now there's 2
Side.
oxygen on the left hand side and right hand side, and 2 nitrogen on the left hand side and right hand side.
Mm.
So we balanced the equation. Have you not?
So to oxygen is 2, but on the right hand side it is 2NO2. So 4 oxygens are there, no?
You multiply the left hand side by 2 again.
So oxygen by 2.
Oxygen
N
by 2. So
plus
N2
2
plus 2
is
and
NO2.
okay. So on the
Understood?
right hand side, it can't be 2n plus O2. It has to be together.
Yeah, yeah.
Okay.
You understood?
Yes.
Acha. Now you can also do one, say, plus hydrogen plus oxygen giving H2O2.
Hydrogen plus oxygen. H2O2.
Hmm.
So it starts off as H2O2 and going to HO.
No, it is going to H2O2, no?
Oh, but hydrogen exists in 2.
Yeah, hydrogen is 2 on the right hand side,
So
oxygen is
there's no need for balancing.
no need for balancing. Exactly.
Okay.
Okay.
Mm-hmm.
Okay. Well, one of the things people always do in these sentences, these are also used for analytical purposes.
Mm-hmm.
Okay. Suppose you want to estimate the amount of silver ion present
Mm-hmm.
in a solution.
Yes.
Okay.
Mm-hmm.
So they say, okay, tell me how many silver ions are there
Mm-hmm.
in a solution. So one of the way we do it is we put hydrochloric acid.
Okay.
Then it will form what is called AgCl, and that will precipitate.
Mm-hmm.
Okay, so silver ion is in solution. So it is, says,
Yeah.
let us see the reaction, silver nitrate, AgNO3
Mm-hmm.
plus HCl
Okay.
going to AgCl
Mm-hmm.
plus water plus
Mm-hmm.
HNO3. What is AgNO3? So HNO3.
HNO3.
Yeah.
Okay.
Because it's just displacement reaction, no?
Mm-hmm.
AgNO3 plus HCl going to AgCl plus HNO3.
Yeah.
Hmm.
So now I have to balance the equation.
Suppose say I get 10 grams of AgCl.
Mm-hmm.
So tell me how many silver ions are there, silver nitrate is there.
In 10 grams of AgCl.
No. I get a product AgCl which is 10 grams.
Okay.
So I'll have to now guess how much of silver nitrate I started with. So first balance this equation.
Uh,
See, AgNO3 plus HCl, I told you give AgCl plus HNO3. Is it balanced?
yes,
It is
it
balanced, right?
is. Yes. Mm-hmm.
Okay. So now you have got AgCl 10 grams.
Yeah.
So what should you do next? You must calculate the number of moles of AgCl.
Moles. Yeah.
Calculate.
So
So go to the table.
143.35 is 1 mole.
Huh?
143.35 is 1 mole.
1 mole. So 10 grams is how many moles?
So 10 divide the answer,
Hmm?
which is 0.697.
Just 1 minute. Just 1 minute. I'll do it. 1 minute.
Yeah.
Yeah. Hello. Where are
I
we?
was saying it's 0.0698 moles, 10
Uh,
grams of
So,
AgCl.
so AgNO3 has to be that much only, 0.0693 moles.
Mm-hmm.
So
Yeah.
now convert that mole into grams. So
Didn't
calculate
we
the
just
molecular
convert 10
Ag.
grams?
Mm,
So I have to find first 1 mole of AgNO3.
Yes, correct.
Okay. Which is 169.9
Mm. So now that is one
grams.
mole is so much. So how many moles here? 0.06 moles.
Yes. So that 0.0698 times the
Mm,
answer I got just now,
Yeah.
which is 11.8
So
86.
so number of silver nitrate present is that many grams.
Mm-hmm.
So you are able to back calculate, no?
Yeah.
So you started with so much of silver nitrate.
Yes. So I started
Then you
with
can calculate how much silver is there in silver nitrate.
so what the 11.8586 that we just got
Is the grams. It's a gram. That is the weight of
of
AgNO3.
AgNO3.
Yeah.
Okay.
Now AgNO3 molecular weight is how much?
169.9 grams.
9. Okay. Now,
Yeah.
so from that, can you 169 has how many grams of silver?
Huh?
Your molecular weight has how much silver?
So I have to find the molecular weight of
Add
silver
the
now.
molecular weight. No, AgNO3 added Ag plus NO3. No.
Yes.
Ag, what was the atomic weight?
116, 170.
What Ag's atomic weight?
No, not AG's. AgNO3.
No, no. That is 1.
AG's atomic weight is 107.9.
So 170, whatever it is, has 107 grams of silver, right?
Yes.
So whatever you got silver nitrate, that will tell you how much silver is there. No,
Yes.
that's all. So they'll say how much silver is there in silver nitrate. You should be able to calculate.
How would I calculate? I'm sorry.
You got what is the molecular weight of silver nitrate?
169.9.
So 169.9 grams has how much of silver? 7
107.9.
grams, correct?
Yes.
So 10 grams of silver nitrate has how much silver?
10 grams of silver. So, okay.
I mean,
Okay.
whatever you got, 11 or whatever you got. I'm just saying.
11.86.
So 11.8 has how much silver?
Uh, so 11 point, about 7.5 grams.
So silver in that silver nitrate, what you have got is only 7 grams.
Okay. Okay.
So suppose you go to a shop to sell, say, silver.
Mm-hmm.
Now that won't be pure silver. There'll be some other things.
Mm.
Okay. So this is one of the ways to measure it.
Mm.
Convert it
So
into chloride.
first we found the how much the molecular weight of AgCl,
Hmm.
and then because we have 10 grams of AgCl, we found
Hmm.
how many moles is
So
10
the
grams of
10.8
AgCl.
is how much of silver you can always calculate.
Mm-hmm.
Okay.
Okay.
So this is what happens when you go to sell your gold ornaments.
Mm.
What he does, he melts it and removes all the impurities.
Mm.
So he weighs
Yeah.
your ornaments. Suppose say there is 40 grams.
Mm.
then that follow. Nowadays there are machines which will tell you how much gold. Suppose it is a 24 karat gold, then they will tell you this much is the gold there. If it is 18 grams, it will be 18 karat gold, it will say so much only is there. Okay, so from that, so the shopkeeper will melt and give you the gold. Okay.
Yeah.
So you can actually not only measure but also get the right amount. So this is how this measurement for commercial purpose, because gold is very expensive.
Yeah.
Understand? So all this calculation becomes very handy. And this branch where you do analysis called analytical chemistry.
Okay.
We'll study that as a separate subject for given. Suppose water has what are the elements present, or there's what called a salt is given. Tell me what is the salt. These are all experiments we do. Okay, but this calculation is very, very important. Okay, I'll send you some exercises for you to balance. I've done only simple balancing. There are complex ones also.
Yeah.
Okay, and I'll teach you how to balance an equation. That's a method also. Until you do it yourself like this, you won't be able to appreciate that. Okay.
Yeah. Yes.
I think we'll stop here today. You had some basic idea, right?
Yes,
the mole,
definitely.
grams, pressure, volume. Next time I'll derive the gas equation for you.
Okay.
How to correlate, how to arrive at Avogadro number and things like that.
Yes.
So tell me, when do you want the next class so that according to
I was talking with my mom and we agreed to have that we can have 2 lessons per week now.
Okay. So you give me the dates and time. I will do it.
I'm free on Wednesdays from now on. My Wednesdays are free. So are my Mondays, but I'll need to change timings because I can't have classes at 3:30 because my school will have started.
No. So you tell me the time. Whatever the Indian time is, you let me know. I'll do it.
Okay, I'll tell you. I'll check it out. But Mondays and Wednesdays, I'll be free.
Okay.
Yeah.
Okay. So now you go to next time. We'll focus on that. So next class will be on Monday.
Monday, yes.
Okay. So just send me the time which is convenient to you, Monday and Wednesday, and we'll make it a permanent. Okay.
Okay, sure.
Okay. So try to go revise what we did today.
Okay. Yes, definitely.
Okay. Because once you're foundation, you will automatically start doing problems.
Yeah.
See, is a qualitative. We are moving now from qualitative to quantitative subject.
Yes.
Okay.
Yes.
And it will be a lot of fun doing it. So don't worry.
Yeah.
Okay. Yeah.
Okay.
Okay. Bye-bye.
Bye.